hope that yesterday's exam went well and that you found that coming to Watobe made a difference and helped you to be able to answer these questions. All right, so now what I'm going to do is, Coco, I just need to share my screen because I'm working on yours.
Sure. No, I'm going to stop sharing mine.
So can I stop your other? Okay.
Yeah, I'm going to stop my share now. There we go. And then you can share yours.
And then I can share mine. Hold on one moment. Why is it not letting me do this? For some reason, it doesn't want to let me share my screen. I don't know what I'm doing wrong.
Well, we can see your screen now.
Wait.
It's just your Zoom is in the way.
How's that?
But we can see the screen.
Can you see the screen?
Yes, you just need to close the Zoom. There we go. Yeah, perfect.
Is that fine? All sorted?
Yes, ma'am.
Okay. All righty, let's get cracking grade 12s. We don't have time to waste. So what I thought I would do, Hamid the other day asked if I would prepare a lesson on some circle geometry. So that's what I decided to go ahead and do for today. So we've done all sorts of things. So yeah, because nobody sent to you. Okay, so question number 8 was supposed to be part of your do now. These are supposed to be questions that are super easy for you guys, having done grade 11 circle geometry. All right, so they've told us that MP is the diameter of the circle centered at O, and they tell us MP cuts the chord NR at T, radius NO and chords PR, MN, and MR are drawn, and then they tell us that angle R1 is 69. Determine with reasons the size of angle R2. Okay, so Timothy, how big would R2 be and why? Do you know, Timothy? Okay, so the diameter is MP. The diameter subtensor, right angle at the circle. Okay, exactly. So 21 equals 21 and angle in semicircle. Okay, and here there would be 1 mark, 1 mark. Oh, Timothy, you're busy making coffee. Oh, okay. All right, angle O1 is the next angle. Okay, so I hope the rest of you can see this. If you can put your fingers at M and N. So from M and N, you go to O1, go back to M and N, and then you're going to go to R. So in other words, O1 is going to be double 69. Okay, so O1 is going to be equal to 138 degrees, and the reason here is angle at center equals 2 times angle at circumference. Okay, so again, statement, reason. All right, next one, M1. Okay, easiest way to do M1. Again, if you put your fingers at N and P, follow N and P to R, you get to R2, go back to N and P, and follow your fingers to M1. Okay, so M1 is going to be the same as R2, and we already know that R2 is 21. What's the reason for this, guys? What do we call this, what I've just done now? Angles in same segment. That's it. Good, Jaden and Fatima. Angles in the same segment. Good job. Okay. Obviously, there's another way to do that, but we want to try and do things the shortest way possible, especially if it's only worth 2 marks. Now it says we need to work out M2 if it is further given to us that NO is parallel to PR. So I don't know about you guys, but straight away, when they tell me that, I sort of think to myself, okay, well, I can make a Z shape here. So that means that angle O2 is going to be the same as P. I already know that that's 90. So if I can work out what this is, then I can use angles of a triangle to work out M2. All right, so how are we going to work out what O2 is? There's two ways we could do that. You could either do adjacent angles on a straight line since you have O1, or you could do exterior angle of triangle, which means N1 and M1. But I suppose then you'd first have to explain why N1 equals M1. So I guess adjacent angles on a straight line is easiest. So O2 would be equal to 180 minus 138 would leave us with 42. So that would be adjacent angles on a straight line. And therefore, P, there's nothing else at P, so we can call it that. P would be equal to 42. So therefore, angle M2 would be equal to 180 minus 90 minus 42, which would leave us with 48, if I'm correct. And that would be sum of angles in triangle. Okay, does that make sense to everybody? Questions, queries, comments? All good. Good stuff. Okay, so good. Thanks, Chad. Thanks, Pearl. So that's the sort of question matrix where you want to get full marks. All right, so there's no reason why we shouldn't be able to get, how much was it out of 10? Why we shouldn't be able to get 10 out of 10 for that. Okay, so let's go on and have a look at the next question. Now here things start to get a little bit more complicated. All right, let's have a look at what's going on over here. Okay, so in the diagram, we've got smaller circle ABTS and bigger circle BDRT that are given. BT is a common chord. Okay, so common chord means it's a chord in both circles. And straight lines STD and ATR are drawn. Okay, so STD is this one over here, and ATR is that one over there. Chords AS, so that's this little one over here, and DR are produced to meet at C, okay, which is a point outside the two circles. And then they've also told us that angle A is equal to X and angle R1 is equal to Y, and they've labeled both of those for us. Okay, so a pretty typical question starting off. They've said to us that they want us to name, giving reasons, another angle equal to X and another angle equal to Y. Okay, so let's go back and have a look and see what else could possibly be equal to X. Anyone got any ideas here? Instead of me telling you, can anyone tell me? There we go. All right, so I don't know if you've seen this, the rest of you in the chat. Pearl's put the answer. She said angle B1, and she says angles in the same segment. Okay, so Pearl, that's perfect. Let's get that down. Okay, so 9.2.1a B1 equals X. Angles in same segment. Good, Pearl. Okay, then 9.2.1 part B, another angle that's equal to Y. Okay, again, I'm not going to tell you. Let's see what you guys come up with. What do you think? Anyone got an idea here? Notice this, I'll give you a little hint then, okay? If you look at where R1 is situated, okay, R1 is an exterior angle. RDBT is a what? What is RDBT? Cyclic quad, exactly, it's a cyclic quad, okay? Chad, we don't know if it's a palm because we don't know that RD is parallel to TB and that BD is parallel to TR, but it is definitely a cyclic quad because it has 4 points on the circle, right? So what do we know about the exterior angle of a cyclic quad, guys? The exterior angle of the cyclic quad is equal to the opposite. Which angle? Opposite interior angle, indeed, Chad. So what is the opposite interior angle to R1 in this case? B2, that's it. Good, yes, you see it now. Okay, it's difficult with all these lines all over the place, but that is quite right. Okay, good job. So we're going to say that angle B2 is equal to Y, and that is because of exterior angle of cyclic quad. Okay. All right, so 2 marks there. Next one, 9.2.2. They will definitely give you something like this tomorrow. They always do. You have to be able to prove that a quad is cyclic. So I would definitely expect a question like this. So before we jump in, let's go and highlight the quad they want us to prove is cyclic. So it's quad. Let me see if I can do, is that, I think that's highlighting. Let's use yellow. Okay, so quad SCDB. SCDB. So it's that over there. SCDB. So that's the quad that they want us to prove is cyclic. So when it comes to proving quads are cyclic, there are 3 ways that it can be done. Is there anybody who can quickly tell me what that is? They all start with converse. Someone was going to say something?
I'm sorry, it was me.
Okay, Karaba, what were you going to say?
I was going to say the 3 ways to prove.
Okay, go for it. Tell us. Awesome. Go for it. Tell us.
Well, the first one is prove that the converse of opposite angles are supplementary. Converse angles in the same segment. And converse exterior angles of a cyclic quad.
Beautiful. Okay, I couldn't have said it better. Karaba, 100%. Why would we immediately throw away converse angles in the same segment? Why would we not even try that in this case?
Because there's no
bow tie or butterfly. One of you called it a butterfly or angel wings, which I think is much nicer than a bow tie. But yeah, there's no angel wings. There's no bow tie. So we're going to have to get rid of that. Right. Yes. As far as the other 2 reasons are concerned, we've got angle S1, which could serve as the only exterior angle to this particular cyclic quad, but we don't really know anything about S1. And then the other thing, as you said, which is the first thing, is converse opposite angles of a cyclic quad are supplementary. So let's have a look at that. Okay, what do they tell us? Well, if you have a look at the position of angle C, can you see in triangle ABC, we've worked with X and we've worked with Y. All right, so we know what this angle over here is, and we know what that angle over there is. So in other words, we can get angle C in terms of X and Y. All right, so I'm just going to clear a little bit of space, and let's use that as a starting point. Okay, so let me just change the color. All right, so angle C is going to be equal to 180 minus the sum of X and Y, okay, because of the sum of angles in a triangle. Okay, so we're working in triangle ABC, all right? So that means that C, all right, that's fine, let's leave it like that. Is there a way for us to prove SBD what have they told us about? Okay, we don't know if BD is a diameter. Is SB a tangent? Hmm. If angle SBD was equal to 90 degrees, why would angle SBD be equal to 90? I wonder if there's some information that I've chopped off here. Or if I'm just being stupid. Oh, hang on a second. Am I just being dumb? Hang on. Wait. We know what angle B2 is, don't we? We know that angle B2 is Y, isn't it? And we also know that angle B1, oh, there we go. It was just me being a bit off. Okay, that was equal to X, isn't it? Okay, so it goes back to what we had done over here. So angle SBD is equal to X plus Y, isn't it? All right, so that comes from 9.2.1. So in other words, if we now take angle C and we add angle SBD together, we will get 180 minus X plus Y plus X plus Y, won't we? Which means, let's just move this up, that angle C plus angle SBD is equal to 180. So therefore, SBDC is cyclic, and this would be converse opposite angles of a cyclic quad are supplementary. Okay, does it make sense to everyone? Any questions? You guys okay? Yes, you sure? Okay. Yes, Karabo. Thanks, Anne.
Okay, so C plus CBD is equal
SBD.
to 180 minus X plus Y.
Yes, I was just substituting.
Oh, okay.
Okay, so in other words, if I'm saying that C is 180 minus x plus y, I'm putting the C on the one side of the equation and what it's equal to on the other side. And then can you see here to the left-hand side of the equation, I'm adding SPD. So to the right-hand side of the equation, I'm adding what it's equal to. Okay, does that make sense? Okay, all right. So I've been able to show that when I add C and SPD together, I get 180 degrees, therefore making SPDC cyclic. Okay, so converse opposite angles of a cyclic quad are supplementary. Not exactly straightforward, that. Little bit tricky, but the thing in geometry, and this is what I'm saying to you and what I didn't do, and I should know this because I say it 1,000 times, is often you use what you've already worked with in order to help you in the next step. So that's why I was like, you know, what am I doing here? And then I was like, oh, hang on a second, but I know that B1 is X and I know that B2 is Y. So let me use that and see if it works. And indeed it does. All right. So last question here. They want us to prove that SD is not a diameter. Okay. So it's further given that D2 is 30. So where's D2 down there? So D2 is 30. And AST is 100, AST. So that's this angle here, AST. So that's S1 plus S2, that's 100. Prove that SD is not a diameter of circle BDS. All right, so the first thing that we need to establish is how are we going to prove that a line is not a diameter? How would that be done? Using what? And there isn't actually a converse here. But there's something that we could show, and if we showed that that was true, then it means that BD, exactly, the angle subtended wouldn't be 90 degrees. Exactly, Pearl. All right, so where is SD? Okay, so SD is over here. All right, so what we need to do is we need to show that SD is not a diameter because then X plus Y cannot be equal to 90. So in other words, what we really need to do is we need to work out what X plus Y equals. And if it's not 90, we've proved that SD is not a diameter. Does that make sense to everybody? Is that thumbs up? Is that okay, Matrix? Does it make sense to you? Good, okay. All right, so now, in other words, what we're trying to do is we're trying to work out how big X plus Y is. All right, so let's have a look at what we've got. Okay, so we know that the whole thing here is 100. And we know that that's 30. So what can we work with here? All right, what if we work with angle T4? And angle T4 is going to be Y minus 30, and that's because of exterior angle of triangle. And then we know that T1 would also be equal to Y minus 30 because of vertically opposite angles. Okay, so if we know that that and those two are equal to one another, and where can we work? Okay, so then we could work, okay, because it told us that AST is 100, right? So if we know how big this is, it means we could work in triangle AST. So in triangle AST, we could say that y minus 30 plus 100 plus x is equal to 180 degrees. Angle sum in triangle. Sorry, let me move this up. And now we've got an equation with both x and y in it, and we can solve for the sum of x and y. All right, so that means that x plus y, so we'll leave those two on the left-hand side of the equation. And then we'll take 100 over and then 30, so that would leave us with, okay, so because x is not a diameter, sorry, it keeps telling me it's, I don't have electricity at the moment, so I'm working from my phone, which is a hotspot, so the connection isn't great. I'm sorry, it keeps having to sync every now and again. Okay, so SD is not a diameter. Right, and then I could say here line does or can I do nothing about that?
I'm not too sure. I don't think we can, especially
okay,
with,
all right.
I think with load shedding, if you're using data, even the cell phone towers are bad. So
okay,
it
all
might not be
right.
something we can solve. Sorry.
Okay, all right. So I'm sorry I keep disappearing, but that's what it is. Okay, so does that make sense to everybody? Are we okay with that? So we needed to solve for what x plus y is, and if we can show that it's not
sorry
90.
to interrupt.
Yes.
Could you try maybe switching your camera off? I think that might help a bit.
Okay, all right. Let me do that. That's fine. Okay. All right, so there, the camera's gone. All right, how's everybody feeling? Is this making sense to you? Not an easy question either, which is why I wanted to do it. Are there any questions you want to ask me, or can we move on to the next thing? Okay, so Chad, you said yes. Okay, perfect. Let's go on and have a look at the next question. I'm just going to make this a bit bigger. All right. So in question 10, it tells us in the diagram A, B, C, D is a cyclic quad such that AC is perpendicular to CB and DC is equal to CB. AD is produced to M such that AM is perpendicular to MC, and they've asked us to let angle B be X. All right, so what they want us to do here is this. All right, so first things first, they've said prove that MC is a tangent to the circle at C. So again, this is a difficult sort of question because they're asking us to prove that a line is a tangent to a circle. How do we do that? Converse, yes. Converse what though? We have to show that the whole angle C is equal to angle B. The whole angle C is equal to the whole angle B. If we want to prove that MC is a tangent to the circle at C, then angle C2 would be the angle that would be between the so-called tangent, what would be the tangent, which would be MC. DC is the chord, and that subtends A1 at the circle. All right, so answering a question like this means knowing which two angles to prove are equal to one another. All right, so we're going to prove converse tan chord theorem, and we need to show that angle C2 is equal to angle A1. Not C2 and A2, C2 and A1. Now, this unfortunately is the drawback of doing geometry online, is because this isn't in front of you and you can't actually touch the diagram, it really makes it quite a little bit more difficult to work with, all right? But what I want to show you is this, all right? If we want to prove that MC is a diameter, all right, then MC, that's this line over here, there would be the chord, okay? So this would be the angle between the chord and the line that we're going to prove is the tangent. And this chord called DC, follow your fingers from C to A and from D to A. All right, and it's that one at the circle. So in other words, the key to this particular problem, what they're really asking you to do is they're asking you to prove that C2 is equal to A1. All right. So let's have a look at the information that we've got and see what we can work with. Well, first of all, is there any way of us being able to work out how big A1 is equal to? Something that we don't often see, but it does come up every now and again, is this idea, okay? Can you see chord DC and chord CB are equal to one another? Right, so what that means is that equal chords subtend equal angles. So in other words, angle A1 equals angle A2. Angle A2 is going to be equal to 90 minus x, okay, because of angle sum and triangle. And angle A1 will be equal to angle A2, which will be equal to 90 minus x, because of equal chords subtend equal angles. So now we've got A1 and A2 equal to one another. This is equal to 90 minus x. Is there a way that we can prove that angle C2 is also 90 minus x? Well, there's the 90. Can we prove that angle D2 is equal to x? Why would C2 be equal to x? Sorry, C2 be equal to 90 minus x?
Because of tan chord, ma'am.
Because of tan chord, exactly.
Yes, ma'am, which means D2 will have to be x.
Exactly. All right, so because of tan chord. Well done. All right, good thing that you spotted that. Okay, so D2 is equal to x. All right, because of tan chord theorem, which means that C2 will be equal to 90 minus x. So that means that A1 equals, so therefore A1 equals C2. That's what proves it. So you have to make that connection. Okay. Therefore, MC is a tangent. And our reason for this would be converse tan chord theorem. Okay, sorry, I kind of ended up writing all over the place with this. What was important here was in the beginning, A2 being equal to 90 minus x because of angles of a triangle. Then A1 being equal to A2, 90 minus x because equal chords subtend equal angles. Then D2 is equal to x because of tan chord theorem, which means that C2 is 90 minus x. Therefore, you must write this, angle A1 equals C2. This is what proves it. Okay, there would be a mark for this. Therefore, MC is a tangent. You're not going to get a mark for that, and you're going to get a mark for the converse tan chord theorem. These two together would be your statement reason marks. Okay, is everybody happy with that? Could you also use exterior? Yes, absolutely. Yes, no problem. All right, Chad, good. Yeah, 100%. Okay, now let's move on. The next thing that they want us to do, can I rub that off? Just to make space to write. Okay. Actually, hang on a second. I think I was wrong and you're right, Chad. I think that's the only way we could do it. Sorry, I made a mistake. That's actually, I was wrong. It's not tan chord theorem. So here, sorry, it's just the one thing that I wrote. Angle D2 is not equal to x because of tan chord theorem. Sorry, angle D2 is equal to x. My reason here was wrong. It's because of exterior angle of cyclic quad. Sorry, matrix. Sorry, not tan chord theorem. Okay, everything else was perfect. It was just this. Okay, so just change the tan chord theorem to exterior angle of cyclic quad. Okay, and then everything else was 100%. Sorry. Is that okay? Has everybody got that? Are there any questions? You sure, Ayamide? I haven't lost anybody, left anyone behind. Chad was right, I was wrong. Okay. Everybody else is very quiet. Are you sure? Okay, thanks, Benedict. Okay, so then the next question. 10.1.2, we need to prove that ACB is similar to CMD. I think this comes from the 2018 paper, Timothy. I think this is 2018, if memory serves me correctly. No problem. Okay, so now proving that a triangle ACB is similar to triangle CMD. Okay, so now this is something that we should find pretty easy. I'm just going to try and space this out a little bit better than the previous question because the other one really wasn't set out very nicely. Okay, so in 10.1.2, so in triangle ACB and triangle CMD, because they've given it to us, they've actually given us clues. They've told us which angles are equal to one another. But straight away, can we see that angle C and angle M would have to be equal to one another, right? Because they're both equal to 90. So angle M is equal to angle C because they both equal 90. That was given to us. Okay, so next angle that we are looking for okay, well, we know from the previous question that D2 was equal to 90 minus X, didn't we? And we know that sorry, my pen's done this. It's so frustrated. And we know.
Apologies, Lee.
Yes.
Was D2 not equal to X, not 90 minus X?
Oh, sorry, it was C2 that was 90 minus X, wasn't it? Sorry, it's because I've rubbed it off now. Correct. Thank you very much. And this was equal to X, wasn't it? That's right. Okay, so then we could also say in point number 2 that angle B equals angle D2 because both equal X given. All right, then in point number 3, I suppose we could say angle C2 equals angle A2, angle sum and triangle, or they both equal 90 minus X. It doesn't really matter. So C2 equals A2. We've actually already proved that above, but let's just say sum of angles in triangle. So that proves that triangle ACB is similar to triangle CMD. Reason, angle, angle, angle. Okay, so that's not meant to be a particularly difficult question. That's out of 3 marks. That's fine. Hence or otherwise. All right, so now when they use the word hence or otherwise, they mean that what is following has to come from what we've already worked with. So that means that this CM squared over DC squared equals AM over AB has to come from us proving similarity. All right, so what I would do to start off question 10.2.1 is write down the proportions that arise from triangle ACB being similar to triangle CMD. All right, so in other words, I'm going to do this. Let me just move all of this up. Okay, that's what we want. There's our question. All right. So those of you that were here when we did geometry the last time, this is when, remember how we spoke about first 2 over first 2 equals second 2 over second 2 equals first and last over first and last? That's what I'm talking about. All right, so in this case here, we've got that AC over CM would be equal to CB, so second and last over MD, would be equal to first and last AB over first and last CD. And then that would be corresponding sides in proportion. Let's just check BC over MD is AB over DC. Okay, so we want and DC over MD is AB okay, but then we also know, hang on, we also know that DC and CB are equal to one another. Okay, because we want to make, we want to make DC squared, right? We want to make CM squared and we want to make DC squared. So if we go back and we have a look at our diagram, can you see CB? So in other words, this bit over here, CB is equal to DC, all right? So what I'm going to do is I'm going to substitute. I'm going to work with these two proportions at the end here. Ach, yeah, I can't deal with this. Seriously, this pen drives me insane. Sorry, Matrix. Okay, we're going to work with these two proportions at the end here. And we're going to need to be clever because what we want to create is CD squared, right? Now, I've got a CD here. I could make CD squared by cross multiplying CB and CD together. If I go back and I go and have a look at the diagram, CD is equal to CB. So I'm going to take this and I'm going to substitute. So CB is equal to DC. So DC over MD is equal to AB over CD. Cross multiply, and that's going to give me DC squared or CD squared. It really doesn't matter. Let's go DC squared because that's what they gave us in the answer, is equal to AB times MD. Okay, so now I've got one part of my problem, all right? Now I want CM squared. So how am I going to get CM squared? I don't have, I've got CM here, but I don't have anything else here. So maybe there is another triangle that I need to go and work in. Let's go back and go and have a look. So they want us to use AM. Okay, so if they want us to use AM over here, that means that we need to work in triangle AMC and triangle CMD. Otherwise, we can't get this AM that's over there. All right, so now I'm going to need to prove congruence, not congruency, similarity in those two triangles. Okay, so I'm going to work in triangle AMC and triangle CMD, and I'm going to prove that they are similar to one another. Okay, so first of all, M is common. All right. What else could I say? Well, I've already proved that C2 is a tangent to the circle. So C2 is equal to A1, isn't it? Because of tan chordal proved above. So C2, actually I should maybe, it doesn't matter. C2 equals angle A1 because of tan chord theorem. And that means that the remaining angles, so in this case, D2 and what would it be? C1 plus C2, I guess. And that would be angle sum and triangle. Okay, so therefore, triangle AMC is similar to triangle. Let's make sure I've got the order correct. So A went with C, A went with C, M is common. Okay, and then, yeah, D at the end. Okay, perfect. All right, so angle, angle, angle. And it's very important for me to make sure that I've got my order correct over here, grade 12s, because again, I'm going to write a proportion statement, just like I did over here. Right? So if I get my order incorrect, then my proportion statement isn't going to make any sense and I'm not going to be able to solve my problem. So again, I'm going to go to corresponding sides and proportion. I'm just going to move the diagram up. Okay, and now we can state that. Let's just have a look at everything. All right, so first and last, AM over first and last, CM is equal to MC. There's my CM squared coming through. over MD. All right, I don't even need to write the rest of it, to be honest with you. You can if you want to, but I mean, I've got what I was looking for, which was my CM squared. Okay, so corresponding sides in proportion. And now, okay, I'm going to cross multiply. That gives me CM squared, and it is equal to AM times MD. Okay, so now matrix, I'm ready to put everything together. They said they wanted, let's just move this up again. They said they wanted CM squared. Let's just go back to the question, CM squared over DC squared. All right, so I've got CM squared over here in the black, and I've got DC squared over here in the pink. All right, so I'm going to put CM squared at the top and DC squared at the bottom, and hopefully everything works out. Okay, so CM squared, I'm just doing it in the middle of the screen. CM squared was AM times MD. And that all goes over DC squared, which was AB times MD. All right, and what I know in maths is that MD divided by MD will give me 1, and that means that CM squared over DC squared will be equal to AM over AB. All right, so hopefully we've got that correct. Let's just have a look. AM over AB, yeah. All right, how do you feel about that? That's also quite a difficult question. What do you think, Matrix? Is everybody all right? Shell-shocked? Shame, you're all so quiet. Okay, so Pearl says she's fine. The rest of you, are there no questions? Sure, Chad. Okay, Ayamide, thank you. Okay, so we've got 2 seconds left. Let's just finish this off. There was one more question there. So AM over AB equals sine squared X. Okay, so AM over AB is the same thing from here. So maybe there's a link between these two. All right, so sine squared X. All right, so how could we get sine squared? Okay, so, well, maybe what I should ask you rather is, where does sine X come from? So if I say sine X, let's just write down all the angles. So that was X over there. That's X over here. What was angle? That was 90 minus X, wasn't it? This one over here was also 90 minus X, which means that this entire angle over here is equal to X, right? Okay, so if I work in this big triangle, AMC, sine X is going to be what? Opposite AM over adjacent AC. So AM over AC. If I work in this triangle over here, sine X is going to be equal to opposite AC over hypotenuse AB. So if I make AC the subject of the formula, then AC would be equal to AM over sine X. Working in the second one now. If I make AC the subject of the formula, I make AC the subject of the formula, then AC would be equal to sine x multiplied by AB. Okay, so if those two are equal to one another, it's just a manipulation, isn't it? Okay, so if, last thing over here, if AM over sine x equals sine x times AB over 1, then sine x squared will be equal to AM times AB. What have I done wrong?
Then it would be sine x squared AB times AB is equal to AM.
Just say that again. It would be?
You see where you cross multiply the sine x? It would be sine squared x times that
Yeah.
all of that is equal to AM, and then you'd have to.
Oh, of course, of course. I'm just being dumb,
Right,
aren't
right.
I? Sorry, quite right.
divide.
Thank you. Let me just move this over. So that would be sine squared x over AB, hey, would be equal to AM. Sine squared x. No, that would be times AB. Sorry.
Times AB.
Of course it is. Sorry, guys. My brain is clearly fried at this point. Okay, so it's sine squared x AB. Beg your pardon, equals AM. Divide both sides by AB, and sine squared x equals AM over AB. There we go. My apologies, got there in the end. Okay, so that's it, matrix. I chose these two questions because I thought that they were a little bit more sort of challenging. I hope this makes sense. Are there any questions? How are you all feeling? You've been very quiet today. Okay, I'm glad Ayumide, that's great. It's getting there, yeah. So you've got the weekend to study, okay, Timothy? So try and do as many past papers as you possibly can. Cool beans. All right, well, in that case, I'm going to hand you back to Coco. Thanks to everybody for coming this morning. It was really nice to be able to do this last session with you, and all the very best for Monday and for paper 2. And yeah, when you get your results, please do let us know, because obviously we would like to be able to see if we've helped, and hopefully we have. So yeah, please let us know. Done already, I know. Can you believe it, Chad? An hour's gone. Crazy, hey? 1 hour gone. Shame, were you hoping it was a 3-hour lesson, Chad? I might be, shame. I might be teaching you some really funky mathematics by the end of it. My brain is fried. Okay. All right. Well, thank you. I'm sorry to disappoint you. Oh, thanks, Timothy. Me too. I would have also loved to have spent more time with you guys, but unfortunately it was just an hour. Thanks, Karaba. It's a pleasure. Absolute pleasure. I hope all of that made sense. No problem, Pearl. Pleasure, guys. Yes, good luck to everybody. Okay. We'll be thinking about you. I was thinking about you on Friday. I'll be thinking about you on Monday as well. It's a pleasure, Neo. Take care.
I'm a bit hard, so I think this is the last time we're going to be
I
seeing.
know it is. I must say, I feel tears pricking my eyes. Anyway, it's always so difficult to say goodbye to matrix. So yeah, good luck, everybody. We're behind you all the way.
Okay, guys, there isn't much from our side since this is the very last lesson. Sorry, guys, I'm sitting at a McDonald's. I've also been load shedded, so if you're hearing people, it's because I'm at a McDonald's. Guys, really well done to all of you. You guys have worked so hard this year. And yeah, the best of luck to all of you. Please do let us know on the Watobe chat how everything goes. We'd like to keep up with you guys. And
Yeah,
I'll
definitely.
put of your names in the matric paper when it comes out. You guys should let us know how you do. I'm hoping to see a couple of distinctions for maths, hopefully.
Yeah. Yeah, please do. No matter what you get, please do let us know how it went and if, coming to Watobe made a difference. We would really love to hear from you. It's always so hard for us to say goodbye to the matrics and, we never hear from you again or get to see where you've ended up in the world or anything like that. So yeah, if you do let us know what your results were, that would be great. I would be certainly very grateful to hear from you. Okay, so all the very best for Monday. Bye, everyone.
Remember, guys, if you need to rewatch any of these on paper 2, there's quite a lot of them. You guys can find them on the website, watobe.co.za, or you can find them on YouTube as well. You can go and rewatch some of the things that you've done with Lee for paper 2. There's a lot more on paper 2 that we've done throughout the year. So it's not just the guys. You can go rewatch some of those just to get a sense of everything that's going to come out in the paper. So don't be too hard on yourselves. I know it was just a 1 hour lesson, but thanks so much, guys. Good luck, everybody, for paper 2. Good luck. Pearl's writing paper 1. She's IEB. She's writing paper 1 tomorrow. Good luck to you as well.
All
and
right.
guys,
Good luck, Pearl.
Bye-bye, everyone.
Bye, everybody. Take care.